So based on what was mentioned in the video previously, I would just like to take a second to bring our focus back to our syllabus, CSEC syllabus, that is, on page 36. Now on the under the first column on your left, which has the heading of special objectives, if you're looking at your syllabus, we have describe one hazard and one useful application of static charge. And over our second column, just beside that to the right, we have the caption for that second column is the explanatory notes. And we are given some examples. We have electrostatic painting, which I mentioned, lightning strikes, which is a hazard, and it was mentioned in the video previously. Dust extraction, that is a useful application of static electricity or static charge. Photocopying, static buildup on vehicles, that's a hazard, and the effects of local charged ionized atmosphere. Now that is the one that I want you guys to look into for me, and send me some feedback on that one, what you found out about the effects of a local charged ionized atmosphere. I want somebody or anybody to find out if it's a hazard or if it's a useful effect of static charge. So for each one mentioned, please go ahead, do a little reading on it, broaden your understanding of each. Just don't stick with the general example. Get some details on it. Okay? So we like to continue and move on to where we were. Now we want to look at charging by friction. Charging by friction. Now we know that in order for static electricity to occur, there must be some unbalanced charges or separation of two different charges. Okay? And this is easily or most commonly done by friction. Now, friction is a force which is generated when two objects move relative to each other. Okay, I'm just putting it simply. Friction is just rubbing something against another surface. All right. Now, over here to our right, that's right here, we have a diagram of an atom. We have a diagram of an atom. If you look carefully, you can see that here we have two subatomic particles. What are these subatomic particles on the perimeter of the atom called? Yes, you're correct. They're electrons. And in the center here, we have some positive subatomic particles. The central region here is called the nucleus. Good. Now, inside the nucleus, we have two sets of subatomic particles. One set possess charge, the other set does not. So, the one that we're concerned with here are the positive charges, and they are called protons. Very good. Now, the atom in and of itself, an atom, the overall charge on an atom is neutral. Let me say that again. Even though atoms have positive and negative charge, the overall charge on an atom is neutral. The atom overall does not have any charge. And let's see why. if we have a positive +2 charge, now let's say that we have +2 representing our 2 protons here, and we have 2 electrons. +2 minus 2 is going to be equal to an overall charge of 0. You got it. Now, in an atom, what you should bear in mind that in an atom, the number of protons are always equal to the number of electrons. Let me say that again. In an atom, the number of protons is always equal to the number of electrons. So if we have an atom, let's say for example with 19 electrons, how many protons do no, if we have an atom with 19 protons, how many electrons do you think this atom will have? Yes, it will have 19 electrons. Plus 19 minus 19 is 0. So we have a net charge of 0. So atoms in and of themselves have no overall charge, and that is because the number of electrons are equal to the number of protons. So when we put them together, the charges will cancel out. They will cancel out. Now, an atom or a particle that has that have charge is referred to as an ion, and you guys talk about that in chemistry. However, that is not our focus at the moment. We're looking at static electricity as it relates to unbalanced charge. Now, as we already mentioned in a previously in a video, the video before our first video, that electrons are found on the shell of atoms. Here they are. Protons are in the nucleus. They are trapped there. They can't really move per se. Now, because the electrons are on the outer shell revolving around the nucleus, they are exposed. So if I should bring another atom close by with electrons and say this is one material over here, and we rub it against another material with some atoms there, we find out that we can get electrons transferring from one atom to another. So let's say that electrons from this material moves over here, and this initially, where's my eraser? Now let's say that this had 3 electrons on it, and therefore we have 3 protons in its nucleus. Alright, now it had this atom over here, this one, it has 3 protons, 3 electrons, so it has a net charge of, you got it correct, 0. This one over here initially had 2 protons, 2 electrons, so it had a net charge of 0. Let me see if I can demonstrate the math on the left side here. So it's 3 minus, it's 3 protons, 3 electrons, overall charge 0. And this one, it's 2 protons and 2 electrons, overall charge 0. Good. So let's say we take two different pieces of material containing these atoms and rub them together. what you're gonna find out, or what you'll have happening, is that electrons may be able to transfer from one set of atoms over to the other. So let's say that this electron right here moves over here and is transferred, and it doesn't really attach to the atom per se, but it's hovering somewhere around the surface. So it moves and it comes over here. So over here now we have a different setup in terms of the number of protons and electrons on each atom. So here, over on this side, we still have 3 protons represented by positive 3. However, we've lost an electron. We've lost an electron, so we have 2 negative charge. We have 2 negative charge. So we have 3 protons, 3 positive protons right here, represented here by the positive 3, and we've lost an electron, so therefore we have 2 electrons remaining. So let me scratch this electron away. Let's get rid of it. So now we've only have 2 negative electrons represented here by our minus 2. Now 3 minus 2 is going to give us, yeah, you're correct, that's going to give us 1. So we have an overall charge of plus 1. How did we get this? Let me write it a bit neater, and I'm asking you to bear with me a bit. So let me get it over here. So how did we get this positive 1? What we did, guys, look at this. We have 3 positive 3, which represents our 3 protons, minus 2, which represents our 2 negative electrons. So we have an overall 1 plus charge that does not have a negative electron charge to cancel it out. We only have 2 negative electron charges. Now let's see what's the charge on our other atom over here, the one on the right. Now if you notice here, this atom to the right, the one that I just ticked, yeah, that one, it has 2 protons represented by our positive 2. And how many electrons do we have now? Let's see, let's count them. We have 1, 2, 3 plus that third one which it has gained. Now, so instead of that, we have minus 3, which is our 3 negative charges. So we have minus 3 right there. Now 2 minus 3 is going to give us 2 minus 3. Yeah, you're correct. It's going to give us negative equals minus 1. Negative 1. So on this side we have an overall minus 1 charge. So basically that is how charging by friction comes about. It comes about by rubbing 2 different materials together. Some will get electrons, some will lose electrons. Please bear in mind, the object that gains the electron, and in this case it's the one on the right, the object that gains the electron will have an overall negative charge because it's gaining something that's negative, so it will become negative. The object that loses the electron. In this case, it's the atom on the left over here. This one on the left. And it will gain an overall positive charge. So you can look at it in terms of, if you're losing negativity, you're becoming more positive. So if you lose something that's negative, you become more positive. If you gain something that's negative, you become more negative. So let's look at a video which demonstrates this charging by friction at work. Okay, let's wait for it to come up. And we're waiting.
How did I do that? What was going on there? Was it magic? No, it was science. Well, what you didn't see me do was rub this straw on this fur and charge it up. Well, what do I mean when I say charge it up? Well, through science, we've discovered that all matter is made of positive and negative charges. And sometimes, some of that matter, we can actually rub off only the negative charges. And that allows us to do some really interesting things. Remember, by me rubbing this straw on this fur, I'm putting more negative charges on the straw. And through science, we've discovered that positive and negative charges attract. They come together. Think of it like this. When the charges are different, they want to come together. But when the charges are the same, they want to push apart. And scientists call that static electricity. So now let's take a look at this. So I have a can, and remember we said that all matter is made of positive and negative charges. This can is not charged, so it's made of positive and negative charges. Now watch what I do here. I'm going to rub this balloon on the same fur that I rubbed the straw on, and it's going to pick up a whole lot of extra negative charges. What do you think is going to happen when I take this balloon and put it toward the can? Will the can push away, or will the can roll toward the balloon? Let's take a look and find out. Here we go. Negative charges on the balloon. The can is made of positive and negative charges. What just happened there? The positive charges on this can were attracted to the lots of negative charges on this balloon. Let's see if we can do that again and see how fast we can get this can going, maybe race it off the table. Can races with static electricity. So remember we said all matter is made of positive and negative charges, and that also holds true for liquid matter. Here I have a container of water and I have a cup with a hole punched in the bottom. I'm going to fill this cup with water, hold it up and let the water drip out the bottom of the cup, and then hold my balloon up to that stream of water. Let's see what happens. Is the water going to be pushed away from the balloon, or is it going to be pulled toward the balloon? So now I'm going to rub the balloon and charge it up with lots of negative charges. Hold up my cup, and you can see the water is pulled toward the balloon. So what does that mean? Well, I had a lot of extra negative charges on here. What kind of charges attract? Well, opposite charges attract. So that means this water must have lots of positive charges. So what does that mean? That means as I rub the balloon on the fur and I charge it with lots of extra negative charges, if that water is pulled toward the balloon, that water must have positive charges in it. So we know that balloons can pick up extra negative charges, but I have to wonder, can other things pick up extra negative charges? So to test this out, we have lines of just torn up little paper called confetti. I have a comb, a plastic fork, and a plastic bat. And instead of using fur, we're going to try using wool. Just wool fabric. So let's check it out. Let's start with the comb. Pick the comb up. I'm going to rub the comb on the wool, charging it up with extra negative charges. What do you think is going to happen when I pass it over the torn up pieces of paper? It's kind of jumping onto the comb, but is it really jumping? No. Positive and negative charges attract. It worked okay. Let's try the fork. Charge it up with lots of extra negative charges. Pass the fork over. You can see a few bits of paper are attracted to the negative charges. Now let's try the plastic bat. We charge it up, and you can actually hear and see the paper stand on end as I wave it over, and it jumps right onto the bat. It didn't jump. The positive and negative charges were attracted to each other. So finally, take a look at this game that we made up using static electricity. We call it sharp.
Okay, so we'll just pause it there for now. And what I hope you saw or got from this video is how electrons can transfer from the atoms in one set of a material to another and create this static electricity. Now remember, always remember that unlike charges will attract, opposite charges will not attract, but they will repel. So most of what he demonstrated was showing that for the plastic comb, the plastic bat, and the plastic fork, in each case he showed that you can charge it by friction by allowing it to pick up extra electrons. The paper in and of itself was not necessarily charged by friction, but remember, all matter contains both positive and negative charge. So by waving the negatively charged material over it, it attracted the positive charge that was inside the material or the atoms of the material.